Hey guys, welcome back to 12.5. So in this video, we're going to be talking about rotation and reflection. So these are the transformation matrices that we're going to use for rotation and for reflection. So transformation, for these, we're going to be multiplying by these transformation matrices. So we can think of the when I'm multiplying by this, right, it's always going to be, here's my, here is my pre-image matrix, and then I'm multiplying by a transformation matrix. So when I'm multiplying, I'm going to have my point xy multiplying by the top and then the bottom, right? Later on. So essentially this corresponds with what we're doing to the x value. The first column is what we're doing to the x value, and the second column is what we're doing to the y value. So if a transformation matrix has values along this diagonal, then x and y are staying where they are. I'm just changing them. If it has values along this diagonal, then I'm switching x and y and then possibly also changing them. So what I mean by that, and you're not going to need to have this memorized or anything, but what I mean by that is this particular transformation matrix is 90-degree rotation is going to switch x and y, and it's going to make what was previously y negative. So it's going to change, it's going to change all the y values, make them negative, and it's going to switch x and y. This is just going to change the sign on everything. It's not going to switch x and y, it's just going to change the sign on everything. This one is going to change the sign on the x's, and it's going to switch x and y. This one is going to not change anything, which makes sense because a 360-degree rotation is a full circle, which means it doesn't change anything. So this is just the identity matrix. It's not going to change anything. For the x-axis reflection, x and y are staying in the same place, but all of the y's are going to change sign. Y-axis reflection, all the x's are going to change sign. And if you think about that, that makes perfect sense. A reflection across y equals x is just going to switch x and y, which again, that makes sense. And a reflection across y equals negative x is going to switch x and y and change the signs on everything. So you don't need to memorize what each of these does, but it's good to have kind of a little bit of an idea of what these are doing. But basically, these are the transformation matrices that you're going to be using for rotation and reflection. So let's do some examples. Hopefully this will make a little bit more sense. So first of all, I need to erase this. It says rotate the triangle with these vertices 270 degrees. And then so we're going to find the vertices of the image, and we're going to graph both the pre-image and the image on this plane. So first of all, I need a rotation matrix for 270 degrees. So I'm going to go back up here. 270 degrees is this one, so 0, 1, negative 1, 0. So before I forget that, I'm going to write it here. So that's my transformation matrix. I need to find my pre-image matrix so that I can multiply them together. So I'm given my original points. So I don't have to figure them out. I can just write them down. Those are I have this written backwards. Oops. Because it would be this row, right, times this column, which does not work. That doesn't make any sense. Which means on the last slide I had them written backwards too. I apologize for that. That's what I get for not having actual numbers in my examples. So I would need to switch these. So let's go ahead and do that. Sorry about that. But that is just a good reminder that we can't multiply in whatever direction we want, right? We have to multiply in only in the direction that works. And so for our purposes, though, just know that the transformation matrix will always go first and then the pre-image. So even if it would work to do it the other way around, don't. Always do the transformation matrix first and then the pre-image matrix. Always in this order. And then you will be multiplying this row times this column. So that's why, so this is X and this is Y. So we're essentially taking Y and moving it into the X location. So let's look at how that works. So I have 0 times -3 and 1 times 0. So that's just 0, right? And then if I move on to column 2, I have 0 times -4 and 1 times 4. So this becomes 4. And then I have 0 times 1 plus 1 times 1, which is just 1. So notice that my Y values have all moved to the top row. Now we need to do the same thing with this row. So I'm going to get -1 times -3, which is +3. And 0 plus 0 times 0 is just 0. So this is just going to be +3. And then I have -1 times -4 plus 4 times 0. So that's just +4. And then -1 times +1 plus 1 times 0 is -1. So again, we've essentially taken the y's, moved them to the x location, taken the x's, changed all the signs, and moved them to the y location. Again, you don't need to memorize that that's what it does, but it's good to kind of have an idea of what is going on with these. So let's go ahead and graph the pre-image. So I'm at -3, 0. I'm at -4, +4. And I'm at 1, 1. So this is my triangle. Oh gosh, triangle. Slightly better. Okay, so that's the triangle. And then we're going to graph the 270-degree rotation. So we are at 0, 3. Uh, 4, 4. And 1, -1. So notice that this is in fact the same shape. It's just been rotated. So probably easier to think of this as a 90-degree clockwise rotation, but it's the same thing, right? A 90 degrees clockwise rotation is the same thing as a 270 degree counterclockwise rotation, which is what we did. So those would be the same thing. So this is the same triangle, just rotated by a certain amount. So that is that. So let's do reflecting. So this is rotating. Let's do a reflecting example. So we have a quadrilateral with the given vertices reflected across the x-axis, and we're finding the image matrix, and we're going to graph both of them. So before we do that, we need to figure out what the transformation matrix is for a reflection across the x-axis. So let's go back up here. Reflection across the x-axis is 1, 0, 0, negative 1. So 1, 0, 0, negative 1. And our pre-image is 1, 1, 3, 1, 5, 4, 1, 3. There we go. All right, so in this one, anytime we multiply these numbers, just going to be 0, and these numbers we're just multiplying by 1. So essentially the x values are not going to change, because there's going to be 1 times this number plus 0 times that number, right? 1 times this number plus 0 times that number over and over and over again. So essentially the top row is not going to change, right? Not going to change. The bottom row, we're going to get 0 plus negative 1 times the bottom number. So essentially, the top row is not going to do anything to it because this is just 0. The bottom row is going to change its sign. So it's going to be the same except for with a sign change. Now, if you don't want to use these shortcuts and you just want to go through and do the multiplication because that makes sense in your head and you don't want to confuse yourself, that's completely fine. But I find that to be tedious, so I'm using the shortcut. So that's completely up to you what you're comfortable with. So let's go ahead and graph our pre-image. So we're at 1, 1, 3, 1, 5, 4, and 1, 3. So I have kind of this kite looking thing here, and then I'm going to graph the reflected version. So I'm at 1, negative 1, 3, negative 1, 5, negative 4, and 1, negative 3. So hopefully you can tell that makes sense. That's an x-axis reflection. Everything has been reflected. So it makes sense that the x's would stay the same and the y's would change sign, and that would give us an x-axis reflection. Again, if this one were negative and this one were positive, that would be y stay the same and x's change their sign, and that would be your y-axis reflection. So that would give us the same image over here, reflected over here. All right, so hopefully that helps and makes sense. Let me know if you have any questions. This is the end of 12.5. I'll see you guys later.